Thank you, Jay and Ewan. Hello, everyone, and thanks for joining. My name is Mikko. I'm a customer engineer here in Singapore, and here to share you today more about what Irvin started today and expanded to training and serving in specific. So you've heard lots about machine learning during this week, and Irvin kicked it off. So this session is particularly about taking your custom code into from writing it into getting predictions on production. So we'll be touching some of those services that can help you to set up faster and quicker and more efficiently with Google Cloud AI Platform. And let's jump right in. So kind of to set the background here, machine learning has had tremendous growth over the last 5 years. And we know with such a growth always comes some challenges. And we've been talking to a number of our customers in this, how we can help them. And some of these areas that we'll be touching on how AI platform helps you as a developer, analyst, engineer, is around technology. How to choose the right say model for my business idea, my model. What kind of tools I do have to help me to operationalize this. So going from model to production. So some of the challenges we recently and commonly have most often with our customers is the time it takes from a good idea to getting something in production is just too long. And that's where one of the areas where we can come in. I think Irvin already mentioned some of these around pipelines in a previous session. And then it's around tooling. Tooling is making you more efficient at your work and helping to offload some of that burden that comes with various of tools that go together to make a machine learning operationalized. So kind of touching where we left off yesterday. So here we have our data pipeline. So on the left-hand side, we do have the standard Google Cloud solutions like BigQuery, Dataflow that gets the data into the system. And we'll be looking at today on the right side here, where do you have the AI platform coming in to make machine learning models. And then on the top and bottom, we do have other supporting services. So especially notebooks is something that a number of AI engineers like to take benefit of. And then on the bottom, we do have pipelines supporting to moving this process into operationalized automated system. So let's start off from the notebook, from the top. So as I mentioned, we did a poll with our customers on what tools did they use around ML and AI, and notebooks are probably the most common. It doesn't mean it's the only tool. There are tons of tools. And especially some of the more who are coming to ML from a programmatic background prefer to use an IDA. But at the end of the day, much of the machine learning tooling goes around having a good text editor. And notebooks are really good in a way that they integrate with number of machine learning libraries and tooling very easily, and you can do rapid experimentation. But where AI platform notebook then differs is from, say, running a Jupyter Lab on your laptop, is that once you have your data in the cloud, it's so much easier to get access to that data both quickly and securely that you don't really want to go back to the laptop. And obviously, it's also to make IT security happy so that data doesn't need to leave the cloud if it's business critical or very secure data. And you don't have to worry about having to download your data to your laptop to do work. Also, where AI platform notebooks is very efficient tool for you is that it takes a single click to launch one and shut down one. So when you need it, it's available, and you don't need to really worry about setting up libraries, all that good. If you have gone through setting up a machine learning environment before your own, you know there's obviously lots of kind of handiwork goes into making sure that all the libraries are matching versions, etc. So AI platform notebook has a number of different types of kind of platforms to start off, whether you are doing Python, you are doing GPU, R, you can just get started with single button and you can launch whatever type of notebook you are getting. And it's obviously backed by our compute engine, so you have a wide variety of servers that you can choose from. And at the end of the day, it's the standard open source Jupyter Lab, the latest version. You don't need to do patching on upgrades or like that. So if you've used Jupyter Lab before, you are right at home with a couple of extra benefits from a Google Cloud integration. The other thing is that when you're looking at from a, say, resourcing point of view, if you are doing it on your own and your model size starts to grow, if you are on a single server, you might not be able to scale, add more memory to be able to process data sets faster in memory. But with the notebooks, you can choose any VM available on Google Cloud to back it up from the smallest one, obviously the most cost-effective approach to any size to fit your data set there so you can be efficient about your work. And also, once you start to getting into the training side of things, you want to possibly have a GPU to accelerate the training process so you can iterate faster. And with notebooks, you can similarly choose any GPU available on Google Cloud to help you run those machine learning cycles quicker. And you can also add or remove GPUs just by stopping and starting the notebook. So you don't need to worry about accounting cost for having accelerators lying around when you don't need them. And really probably the best benefit there is that the direct GCP integration is available through the notebook. So if your data is already in say, BigQuery, you can access it with a quick command and get your data into a data frame inside your notebook. And you don't need to kind of download the data and reload it data, but it's directly available there. And with the help of Google Cloud Fast Network, it's all lightning fast. Although do note that you should use the notebook from the region where your data is to get that really the best speed. So now we covered notebooks, and you have already kind of have a code that you want to put into a model. And we'll look at training. Obviously, you can do training on the notebook right as you would go, but the Google Cloud AI Platform training really helps you since it's a serverless and no-ops approach to the training process. So once your models start growing, you know it takes minutes, hours, even days to run this model training. You don't necessarily want to run that on your notebook. You need to keep it running, and you want to outsource that. Obviously, what you can do is set up a VM and like on or GKE and start to do it yourself. But if you don't have already a machine learning infrastructure set up, this is probably the easiest way to start off doing machine learning training at scale. And similarly, you can choose the right infrastructure that meets your requirements, whether it's memory or GPU for that training process, so that you are cost efficient on using just the resources you need to get the model done. And obviously, training only accounts consumption when it's running. So if your machine learning takes model 1 minute, you only account 1 minute of the VM time and other accelerator time, and it shuts down immediately, so you don't need to worry about resources hanging around when they are not needed anymore. And if you've done lots of machine learning training already, you know a big area about getting the right accuracy on your model is hyperparameter tuning, which can be sometimes frustrating because you need to kind of start guessing what might make things faster and then wait again or didn't work. This one improved a little. How about this? It starts to be a very multidimensional problem once those hyperparameters start racking up. And Google Cloud AI Platform Training has a built-in hyperparameter optimization supported directly of the similar command, so you don't need to worry about that. And you can do directly typical, say, grid search, random search, but most efficiently, we have our own black box optimization, which is a Bayesian algorithm that finds the most efficient path to find those optimal hyperparameters for you. So you don't need to run a whole grid to find what combinations there are, but it tries to minimize the amount of effort needed to do that. And this kind of can really save your time as a machine learning engineer, is not having to kind of wait to happen, but they all can happen in parallel, so you can search all combinations quickly and efficiently. We talk obviously lots about TensorFlow, but with machine learning training, we support also XGBoost and scikit-learn out of the box. And then you also have a support for custom containers. What custom container does is that you just provide your module and entry point, and you can kick off training. But that means that you can basically use any library you like and run like a PyTorch on here if that's your favorite library. And lastly, quickly to touch, there is also support for pre-built algorithms. This session was about your custom code, but if you don't want to code, there's also within the training possibility to go from data to model, bypassing the code by using standard algorithms like XGBoost or wide and deep models, etc. So how do I get started with the training? There's a bit of pre-work to be done. So you need to package your code into a certain format. Not to worry, you don't need to do all these 8 files. This is just a recommendation for a medium, large size model, so that if you package it this way, you can be more efficient when it's modularized. But at the end of the day, you really need just a one file to say an entry point. Say, this is my task that I want you to kick off the training, and once that finishes, you'll output the model. But there are other supporting files where you can add, say, setup functionality if you need to load any extra libraries, or you can specify the hyperparameter configuration as the YAML file. And once you kick it off, good practice is to try the local training. So what this command here does is that it takes your training package and tries to run it in your local server where you're at. It could be your AI platform notebook, or it could be your PC if you are running gCloud SDK on your PC. But it really just verifies that there's no gotchas with your training function, and it can quickly give you feedback that does the training kick off. With the cloud, then once that works, you can move to cloud. Cloud has obviously a slight preparation time, as with everything else, it needs to spin up a server or multiple servers, and those take a minute or two to spin up. So that's why having testing it locally is quicker to make sure that everything starts to kick off smoothly. And what you do is you provide basically just the entry points to your program, and a couple of other things like what region you are training in, what machine resources you want to give to the training process. And then you have also your own parameters to the program. So typically hyperparameters and like, these are separated by the double dash in the middle of the command. So everything after that is your custom parameters. So you can specify, like, here's my training data, here's my validation data, and etc., other hyperparameters. And there are obviously multiple scale tiers. So when you go to cloud, you can start off with a single server using, say, basic. It gives you a single server for CPU, 16 gigabyte of memory, and you can give it a go. Or you can specify a whole cluster just by changing the tier, where you can have a master server and then multiple worker nodes that can train in parallel. And obviously with everything else, you can add a GPU. As you know, your training process is GPU bound and you want to accelerate it, you just throw in a GPU and that's good to go. And finally, if you want to try out the Google Cloud TPUs for further acceleration, that's available as well. If you want to specify all these parameters by hand, there is also a configuration file, so you can set individually on what settings you want to deploy for resources. Then to hyperparameter tuning. So as I mentioned, it's built into the training, and you have all these automation happening to you. Recommended to use the black box training, which gives you probably the best price benefit there. The hyperparameters can be pretty much anything. They can be either numbers or discrete values or like. So you can change, say, number of nodes in your layer or your layer type and like, or any variable that's in your code. And the only thing you really need to do to kick it off is to give this hyperparameter configuration file into the same training process, and it will start then doing it in parallel. Here's a sample of that YAML file. So there are a couple of parameters like number of the algorithm, the training objective, etc., to kind of kick it off. But you can just start it off with small and do a bit of researching what parameters do you want to include. And obviously on the code side, you need to provide those hyperparameters as a command line parameter that go into your code, and you read them similar in your code, couple of lines of code. There's an example that gets you kind of integrated from the configuration and then to the running program point of view. One thing to note about parallelism, it's not built in necessarily once you go beyond, say one GPU. And here's a sample of NVIDIA tool that shows like we have 4 GPUs provisioned, but only one is really consuming resources. So within TensorFlow code, you need to specify what kind of distribution strategy you are going to use. If you're using single GPU, that comes out of the box. But if you have multiple GPUs, then you may need to switch into the mirrored strategy. And also, if you want to use the whole cluster to train, you may need to use the multi-worker mirror strategy. There's quite a few options, I think 6 today. It depends a bit on which TensorFlow version you are using and which configuration you are using in terms of machines. But it's all documented if you look up tf.distribution strategy, and you can pick one that fits your code. Otherwise, it's pretty much a couple of lines of code, change in a code, and you can directly take benefit of the distributed training. Then also to mention, if you want to experiment quickly, there is a similar function as you would know probably from AutoML tables or BQML, where you can go codeless approach to getting machine learning models done. So there is about 10 models available for you to directly jump to do that online. So now we have our model and we want to use it. We want to make predictions. So similarly as the training, we do have a serverless and no-code serving platform. And this is something that can then relieve you of the worry of needing to provision servers and patching them and keeping them up to date. But you basically just bring in your model and assign it to a server. The serving function can be both online, so for example, giving predictions to online users, or it can be a batch, whereas you say want to compute a propensity model for your next marketing campaign and who to target. The online supports all the same models as serving does, XGBoost and scikit-learn, and then custom if you want to bring your own serving function, whereas you just provide an entry point and confirm to a certain model, and you can kick off a servers there. And as Erwin mentioned, explainability is available through a couple of those models like integrated gradients for TF. You can look it up. It's really cool. Similarly, for prediction, you just use gcloud command. Everything also available online. You can do that, but you first create a model and then you add version to it, and that spins up a minimum one server, and then if you are an auto scale, it can scale as much requests your model is seeing. And similarly for custom prediction routines, you just have a entry point where your code enters to your code, and then you can kind of load your own model and do whatever you like if you don't want to just have a model for the platform. And one of the reasons to do those is to kind of have the same, routines as like pre-processing done on the serving side as you would do a training side, to make sure that you don't have any skew in between. Prediction is obviously available for testing. You can do it on command line. You can do this command line on AI notebooks, or you can also do it cloud console. You just give the data structure that goes in. But for any machine-to-machine integration, there's an API. You can call directly this API and get those predictions directly available to you. As with anything, everything else, the serving is integrated with the monitoring tools around Google Cloud Platform. So you'll have a standard Stackdriver reports regarding performance, throughput, latency, errors, and you can keep tabs on what's happening with your model. And similarly, if there's any issues, you can create alerts to make sure that you're notified if something is different. So now we covered pretty much the training and serving. Quick note on the pipelines. So as Irvin mentioned, this is a big topic and not going to cover it to here, but it's really what wraps up this whole end-to-end process. If once you want to go from the notebooks to the pipelines, you can put in all that automation and relieve any extra manual work you need to do today, that when you basically go from model to the predictions. AI platform pipelines is built on the open source framework called Kubeflow. You can check it out. It's already been around 2 years, so it has had some good mileage on it, and we have lots of other companies working with us to making it the best machine learning pipeline framework out there. The one on Google Cloud you can spin up today. It's a hosted version of Kubeflow, so it's basically a single click button where you can deploy a Kubeflow system onto your GK cluster, or you can provision the GK cluster at the same time. Where Kubeflow really comes in is that it creates machine learning processes. It makes them composable and reusable. So all of your modules that go into your prediction and training process can be kind of modularized and then defined in a pipeline. How do you go from data to prediction? Typically you would see something like a pipeline, a couple of steps there to show you how things, what steps precede the others. So just before we wrap here today, I'm going to show you a couple of screens so you are more comfortable what we talked about today looks online. So those of you who have seen Google Cloud Console, this is all standard for you, but those who haven't, please register for a free trial and have a look. So there is a lot of cool stuff there. So currently I'm in the AI platform dashboard. Just to note, if you're coming to this first time, you might see two different platforms there. One is the one I'm showing today, and one that we have in preview, you'll see that noted as unified platform. So there is a new version coming up soon, but it's in preview. So today we're just looking at the current version. And everything as with Google Cloud Console starts on the menu on the left. And if you go to the bottom of the list, there is a section for AI, and that's where you find AI platform. So here we have things we talked about. We do have our notebooks. And so I provisioned the notebook since it takes a couple of minutes to spin up. Notebooks are really easy to spin up. And as I mentioned, there is a pre-built notebook for most of your use cases. So you can have your TensorFlow with or without GPU. And if you really want to play with all the combinations of different types of notebook hardware, you're going to back it up. You can go to the custom and define, say, what region you are going to spin it up, what server type you're going to back it up, whether it's going to have a GPU, and it's all available here. And you can also have a look at the cost, what running that notebook does, so you are comfortable with that. So for training jobs, you'll find them under jobs. So I run a simple sample job here earlier. So with everything else, you can zoom into the job, and you'll have all the, logs monitoring available through this dashboard. And you can follow, say, what's my training process doing, get all your debug statements from the logs, and you can look at the configuration, and you can have as many as these available running at the same time. And if you're doing hyperparameter training, you also have the different combinations running displayed here. And once you have your model and you are comfortable to go live with it, you'll have the models. So you can see all regions. I have one model here. And models also come with version history. So that's something that it's handy for you to keep notes on what versions are. And that also helps you to switch between versions. When you have a new version coming up, you can switch the traffic there and see how the accuracy is working so that you are comfortable on going fully live. So that's what a quick preview on how things look like online so that you know where to go. So for homework for all of you watching here today, if you haven't yet, please check these things out. So AI platform notebooks can really help you to speed up your experimentation. Training can help you to scale with your models, increasing growth in size and complexity. And then predictions is something that you can quickly deploy models ready to be used and utilized. And then finally, do check out Kubeflow and AI Pipeline. That's something that is really up and coming and cool to check out. So that's what I had for you today. Thanks for listening. If you have any, if you want to share this session, please share this session with your friend or colleague. And I have Intel following me today, and hope you enjoy that session and keep watching today. Thank you for your attention.